Good morning, I am Daksh Tripathi and I will be briefing you on the working and technical specification of the Hexacopter Drone Project focused to carry out surveillance and drop medical payloads in remote areas. The project is divided into three parts: Multirotor, Telemetry Module, Manual RC Unit and Display and Autonomous Control Unit. The multirotor first consists of an airframe. The airframe is used here is a S550 hexacopter frame and the end-to-end distance of the arms is 150 mm. The arms are made up of carbon nylon and the coupling plate in the middle is made up of glass fiber. It is fixed with a pair of T landing gear system for smooth landing which is made out of carbon fiber. The landing gear are apart 26 degrees and has a ground clearance of 260 mm. The motor used here are Emax 2230 935 kV motors. Each motor can provide a thrust of 860 grams and work on a peak thrust of 18 amps. The RPM generated by the motors is 22,440. There are 6 motors which total generate 5,160 grams of thrust. The propellers used here are 105 carbon nylon propellers of length 10 mm and pitch of 4.5 mm which provide 860 grams of thrust with the motors. The electronic speed controller used to provide required amount of current to the motors are BLDE Emax 30 ampere ESC which when provided of PWM signal from the flight controller works. The power distribution board is used to distribute the power derived from the battery to various and power consuming units. The power distribution board here is located between the two plates of the hexacopter. The flight controller is the main electronic component used on board processing and various input signals like signal from gyro, magnetometer, barometer, etc. It provides the input from all sensors and RC to provide required signals for the ESC, thus achieving desired operation or maneuvers by the drone. The flight controller used here in the drone is the Pixop 2.4.7. The GPS connects with various geosatellites for global positioning, that is, giving coordinates on ground which helps in the flight maneuvers like RTL, loiter, position hold and waypoint navigation. The power management unit measures the voltage and current brings from the battery and gives the flight controller control status of the battery. The battery used here is a lithium polymer battery of 4500 mAh of 35C which can provide an endurance of 60 minutes. The telemetry module has 2 bars, one on the drone and other on the control unit. It works on 5.8 GHz frequency and a range of 1.6 km wirelessly. Gives the status of the drone to the control unit. Now I will switch on the multirotor with the transmitters. Here the multirotor is booting up for various signals from the gyrometer, magnetometer and barometer. The manual RC unit used here is a FlashSky FSI-6 which is a 10-channel transmitter which works on 2.4 GHz. It has a range of 1.5 km. The remote has 2 joysticks to give roll, yaw, pitch and throttle signals to the drone. There are multiple switches located here to provide various flight modes including emergency, motor stop. Now we switch on the RC transmitter. The display and autonomous control unit is based on a laptop in which the software Mission Planner is installed. The software has all options to completely calibrate the autonomous flight controller on the drone. The flight path can be planned using the software on a map by giving waypoint. During the flight, real-time data of the telemetry module is used to display on the laptop. From here we can see the flight modes of the drone. Here the battery voltage and current derived is being shown. From here we can see if the GPS is connected to the global satellites. Here are the yaw status and various operating status of the drone. From here we can give waypoint navigation status to the drone. For example, I have set one waypoint here. First, the drone will fly up to an altitude of 100 meters and then forwardly go to this waypoint, and from here to this. From this waypoint, the drone will autonomously launch RTS status, which brings the drone back to the launching position.